Okay, here we go. We've got a question about a ball being thrown vertically upwards. There's non-negligible air resistance, and we're asked where the acceleration has its greatest magnitude. Okay, hopefully you've had a chance to try it. Okay, let's think this through. I'm going to introduce a few arrows in a second, and these are important. The first one is we're going to think about some of the forces, and that initial one is the weight. Okay, the weight's going to be shown in red. Now, hopefully you're aware that the weight does not depend in this case on the position. We're going to assume that we're in constant gravitational field. So our weight is always acting down. Okay, in each of these positions, A, B, and C, our weight is acting down. I'm then going to introduce the velocity. Now the velocity, as you can see here, probably a bit unnecessary. We've got velocity is going to be going up on the left-hand side and then down on the right-hand side. Now that is going to be important because we now want to also think about our air resistance. Okay, so our air resistance acts in opposition to the velocity. And it also depends on the size of the velocity. Now, this is where it could get a bit complicated. Let's take it in turn. At position A, we're going to call this the air resistance at position A. Now, as we go from position A to position B, notice firstly, our air resistance is acting opposite to the velocity. Okay, now we compare the two arrows here, the two blue arrows, you can see that this one is decreased in magnitude. Why? Well, because we're slowing down. Okay, as we move from A to B, we slow down. And as you're aware, the slower our movement, the lower the air resistance. In fact, at the top, there's going to be no arrow because we're not moving up or down. Have got a non-zero velocity. We've got a zero velocity in the x direction. If we go onto the right-hand side, we're going to add an arrow which is in the opposite direction. Now, why? That's because we're moving down, so air resistance acts up. Why have I done that? Well, our acceleration is going to depend on the sum of these two forces. So really we're looking for the position where the two forces are at their biggest value. Now, if you notice that D, for example, this red and the blue, they cancel each other out. So it's going to be a very low force, therefore low acceleration. Conversely, the biggest acceleration, the greatest magnitude, is going to be where we have two forces in the same direction, adding together and making a larger number, and so therefore our answer here is going to be A. We have both the weight and the air resistance pushing down, therefore producing a larger acceleration. It's opposite in direction to the motion, absolutely fine. This just means that the object will slow down, meaning that air resistance decreases, and therefore we get this nice motion. So the answer here is A.